Hey everyone, welcome to our final video of this series. The contents from this video I touched on a little bit in the introduction to the Year 7 statistics topic, well, video series, but a lot of those ideas I want to revisit and talk about a little bit in this video, both to introduce this idea of surveying and sampling, which we're doing today, but to also just get you thinking about statistics in the real world and what the essence of collecting statistics, what doing any of this is all about. Now, we have been dealing with, and we've talked about before, this idea of this census and this idea of data from populations and studying data. Now, that is all well and good. It's important to know what's happening with populations and doing these big, large-scale surveys about our populations. Now, to redefine population, the population of anywhere, this is the set of all members of a group that is to be studied. A group that is to be studied. So, if we're carrying out a study, we could be looking at a population as being all of Australia, for example, or maybe all of the animals in a particular park, if we were looking at the presence of diseases. Our population could be a study we're looking at for all school students, right? So a population is the set of all members of a group. So taking our idea of a population, right? Let's look at the census idea we talked about before. We carried out a massive survey, a nationwide survey for all of the millions and millions of people in Australia, for example. So all of these guys here, here. I'm just drawing these to fill up the space. I probably should have done this before. Sorry about that. But let's say this entire population here is the population of, say, Australia, which I don't actually know what that is off the top of my head, but that is about 25 million. 25 million people. Now, the reason we don't do a census in Australia every week, for example, is because it requires a lot of effort. It costs a lot of money and time to send out these surveys to every single person in the population. So looking at a population and gathering statistics and data about an entire population, that's great, but it's just not practical to do all the time. So we have to find a more efficient way. So these policymakers and people ask themselves, well, all right, instead of getting stuff from each of these 250 million people, why don't we just take a smaller group here and pull that out? So I take a chunk of people down here and I go, all right, let's look at these 25,000 people instead. 25,000 people. I'm looking at this instead because it's annoying to pull out these 25 million people and survey them all the time. Let me do something smaller with 25,000 people. And this thing is what we call a sample. So, for example, you go to a shop, right? You have these people sometimes giving out these little on a plate, they've got these little sample things, right? So they have these sample cakes, for example. These little ones, right? This is just a smaller bit of the whole thing because they're giving you a sample of this maybe entire cake. It's a little portion of a bigger thing. That's what sampling has to do with. Think about that the next time you go to, say, a supermarket and they're giving you out these little samples. And we're going to think about how we can apply that to an entire population. So let's shift down here. A sample is a subset or a selected group of a population. So, for example, if you wanted to get information about year 9s across Australia, you might not want to go through every single year 9 student, so you may pick the year 9 students in a particular state, for example, in Australia. And then what you get from there, you use that to make a prediction about a larger group. This is the essence of statistics. So, let's say I want to find out something about my 25 million people, but it's too annoying to do it with 25 million people. So I get my subset, my 25,000 people. This is my sample. So my 25 million is my population. My 25,000 is my sample. And I'm going to try to obtain information about a larger group by using a smaller sample. So this particular thing is called a survey. So the purpose of a survey is to take information using a sample. So we take info using, or data, same thing, information or data using a sample group. So we don't want to conduct a thing about our entire population of 25 million people. So we take a sample of 25,000 people because that's easier to deal with. And with this sample group, this survey that we conduct on my sample group, we use this to get information about a larger group. So we make inferences and statements about a larger group using a smaller group. So a survey takes info using a sample group and we'll write to obtain info about a larger group. So that's what these surveys are. Now, some surveys are large-scale things, like a census. You're looking at the entire population. But a survey allows us to take information from a smaller group and we're applying what we've learnt about that to a larger group. Now, some of you may be thinking critically about this and you're going, well, wait a minute, something doesn't add up there. How can you take information? Doesn't that seem a bit wrong to take information about a select few people and then make a blanket statement about all people? Well, yes, you would be absolutely correct. There are certain issues with this system. Statistics is not a perfect system. We have sometimes issues with these smaller surveys. They affect the accuracy of their conclusions. So, this isn't a perfect system. Now, we are trying to think now, we're delving into some of the philosophy of statistics. This idea that, well, you can't just take a sample and make all these conclusions about a big thing. That just seems wrong, to do a survey on 25,000 people and then apply what we know about that to 25 million people. That seems unheard of. Well, those are the questions you should be asking, because there are certain things that can affect the accuracy of the survey's conclusion. Now, I know this is a lot of content heavy stuff, but I want you guys to, at least at the end of this video, gain an appreciation of some of the issues with sampling or surveying. Now, this accuracy can be affected by a few things. What about, this isn't a perfect system, because we can get affected by sample size. The smaller the group we choose, the number of participants in this survey, 25,000 is pretty small relative to 25 million. Or the number just 25 is even smaller. So the smaller the sample size, the smaller the accuracy. If we want to make a conclusion about the millions and millions of people, the 25 million in fact, we're going to need a pretty big sample size in order to make these really big conclusions and obtain information about a whole population. In the same way, the sample may not be representative of a larger group. So we can say sample is not always representative of the larger group. Sometimes it is actually biased. For example, if you're in the government and you're running a survey and you've taken a sample size and you're trying to find out the average income of earners, and you're using that to make decisions about policy, about public policies, things that apply to the whole population. If this small group you take, for example, maybe this small group, this pink rectangle I've highlighted here, maybe you've ran surveys in a really high socioeconomic area, an area where people are, on average, a lot better off. They have a lot more money. And you're taking this group and the information, you're applying that to the whole population. So you're saying, oh, well, the entire population makes this amount of money. That's actually wrong, because something is being skewed here. Maybe the group you've chosen to survey isn't representative of the whole population. Maybe you, when talking about income, you have found, for example, an elite group of maybe high socioeconomic status. And you're using that to talk about the whole population. Well, that's going to give you biased results. That is not indicative of an entire population. And one more error here is, for example, that there may be measurement errors. So there could just be little measurement errors you make in this particular survey, that when you apply this to a bigger population, there's a lot more skewing that happens. Now, I've talked a lot, and if you've been bearing with me this entire time, thank you, because we will get to an example now. But I just want to give you an appreciation for statistics, as well as some of the good things with it. It allows us to make predictions, but some of the flaws as well. And think about how this is used, maybe where you're from, because sometimes we are surveying. Our survey can lead to inaccuracies in the data, and it can lead to decisions being made that are not representative of a whole population. Surveying and sampling is powerful, but to a certain degree. And if done wrong, it can lead to pretty catastrophic errors. Now, let's just jump straight into a question. And this is the idea of interpreting survey results. So we have here, a survey is conducted asking 100 randomly selected adults how many children they have. The results are shown in this histogram. Histograms we covered in year 7, so please look at that if this is something new. And we want to answer, assume that this sample is representative of the population. That's part A. So they've had to add this kind of disclaimer, because otherwise we may get skewing and some of these issues we talked about here. Now, what proportion of the adult population has 2 or more children? So, 2 or more children. We are looking at this part of my histogram here. And what I'm going to do is I have a frequency. So the total amount of people surveyed is 100. So here I have the people that answered. I'm just getting information from my graph. The people that have 0 children is 50. Let's do that in a different color. So 50 people have 0 children, 20 have 1 child, and that looks like 15 have 10. Have 2 children, 10 have 3, and 5 have 4. So if we add this all together, we're gonna get back to 100. So this is all good. Now, we want to find what proportion of the adult population has 2 or more children. Once again, we are looking here. So we're going to add 15 and 10 and 5. So that gives me that I have 30 adults with 2+ kids. So the portion of the whole population that has 2 or more children is going to be 30 out of the 100 up here that were surveyed. So that portion is going to be 3/10. Okay. Now, in the next part, we want to find out now, in a group of 9,000 adults, how many would you expect to have 4 children? Now, this is the idea of us using samples and surveys to make predictions about a bigger population. We are using the 100 people we've asked in order to make a conclusion about 9,000 people. So, let's think, well, first of all, we want to find how many out of these 100 had 4 children. And that is 5. So, the portion of people in this survey that had 5 kids is going to be, let's do this in the same color, 5 out of 100. Because 5 people answered 4 kids out of the 100 that were surveyed. So this can be simplified to 1/20th of the population. So In order to make a conclusion about the 9,000, we want to find what is 1/20th of 9,000. That is the portion of 100. So to find the amount of people we'd expect in the group of 9,000, we're going to find this, the fraction 1/20th of 9,000. So we want to find 1/20th of 9,000. So we're going to multiply 1/20th by 9,000. And that's going to give me 450 people. So we've used the 5 people out of the 100 that we surveyed to make a conclusion or make a prediction, a guess, to say, well, if we interviewed 9,000, how many would we expect? It's essentially saying how many would we expect to have 4 kids out of the 9,000 without actually going and interviewing, surveying 9,000 people. So it is useful, but as we mentioned before, this is maybe a good prediction, but we've got to see. We can't say this for sure. And remember, this is just an estimate. Now, we have another question here, and this will get you to consider a lot of the things we talked about before. Now, think about these 3 methods in part B. Which of the following methods of conducting the survey could lead to bias? Method 1, asking people waiting outside a childcare center. Method 2, randomly selecting people at a nightclub. And method 3, choosing 100 adults at random from the national census and noting how many children they claim to have. Now, I've gone over time here, so I'm going to get you guys in your own time, if you want, to have a think about this question. You don't have to answer it perfectly, but have a think about what we talked about up here. The issues associated with these samples and the potential skewing of data that we got. Think about, are there any of these things? Think of the locations, the settings of where this survey is being conducted. And think about one or more of these that could lead to skewing and why. And you will see now why it is important to select our sample size, our sample that we're surveying, very wisely. Because if we don't, and we try to use that to make predictions about other things, the skewing and the issues that we encountered, the issues we talked about up here, you're going to see this leading to a lot of false conclusions that we're trying to make. But once again, have a look at this question B in your own time and have a think about which of these, one or more, which may lead to a bias in the data and why. But that concludes our series on Year 8 Statistics Data Collection. Thank you so much for joining me on this one, and I will see you next time.